In this video, I'm going to do three questions. These are 1, 2, and 3 questions from the chapter polynomials, right? And that is based on class 10th polynomials. Let's begin with the first question. What you can see, this is an assertion reason based question. Assertion says that x cube plus x has only 1 and 1 zeros. So let's figure out by actually finding the number of zeros. Now, first of all, you should remember that many of you actually consider this to be a cubic polynomial and you say there should be 3 zeros. That's not correct. Let's figure out how many zeros it have. So we'll do the method of factorization. As you can see, we have x common, so this is x squared plus 1, right? Equating this with 0, x is equal to 0, and equating x squared plus 1 is equal to 0. As you can see that square of a number cannot be negative. So we'll say that we can't get a 0 from this part, right? But look into this, x is equal to 0. So what we can see, it has 1 0, not just because it is 0. 0 can be the 0 of a polynomial. We'll say it has 1 0, right? 1 0, only 1 0. One more time. First, I did factorization, and then after factorizing, I equated with 0 the same way as we find this solution. And while equating this polynomial, the other one, with 0, what we realized, it does not have a real 0. As you can see, square of a number cannot be negative. So we are left with x is equal to 0, and therefore it has 1 0. So I can see that assertion is correct, right? The assertion is correct. Now looking for the reason, check for the reason here. The reason says a polynomial of nth degree must have n zeros. That's totally wrong. Right, as you can see, if I write a quadratic polynomial, check here. This is a quadratic polynomial, but it has no zeros, right? So what do you know that for a quadratic polynomial with power as 2, it can have no zeros, can have 1, or at the most can have 2 zeros. So this is a reason is wrong. And what you should know that for a polynomial of nth degree, it can have at the most n zeros, at the most n number of zeros, but not necessarily it have n zeros. It can have no zeros also. One last time, for example, if I write a polynomial of any degree, let's say, for example, if I write for a degree 6, it can have up to 6 zeros, or it can have no zeros as well. So this is what. So we have got to know that assertion is correct, as we have already figured out, but the reason is wrong. So in that case, assertion correct, reason wrong is what? Option C. It is option C. Well, depending upon what options are given to you. Now coming to the next, the question says the zeros of this polynomial. So here we are going to find the zeros of this polynomial. Now, this is x squared minus 3x minus m multiplied by m plus 3. So we can use middle term factorization, and there is an alternate way also, that is by using identities. Let's check here. If I open this bracket, minus m into m is minus m squared and minus 3 times m. Now what I can see that this x squared and this, we can frame an identity, that is applying a square minus b square, right? So let me write down first x square minus m square, and then I'll keep, that's a rearranging. Check from the first, applying identity a plus b into a minus b. So it's going to be x plus m multiplied by x minus m. And for the other two terms, I can see 3 is common, so I'll be taking 3 as common. So it's x minus, since I've taken minus 3 common, it's going to be x plus m. Now from here, you can figure out that this is x minus m is coming common. You can check, sorry, x plus m, we can take for common to factorize it further. So check, if I take x plus m as common, what do we get inside? We get what? X minus m from here and minus 3, right? I have just took x plus m as common. Now, as you know, in order to find the zeros, we equate the polynomials or the factors with zeros. So we'll get x is equal to minus m. And if I equate x minus m minus 3 with 0, we are going to get x as what? Minus m on the other side is plus and plus 3. So we'll declare minus m and m plus 3 are the two zeros of this polynomial. Now we have one more question, that is an MCQ. So let's see it. It says if each root of this is decreased by 2, the resulting equation, the resulting polynomial is this. So this is root and an equation is not a polynomial. It's an equation given over here. Now, one more time, I'll read it to explain it further. What I mean to a question says that if the zeros of this, when decreased by 2, results in this. Now, it's difficult to find out the zeros of this and comparing with this. But then alternately, look into this. We can find the zeros of this polynomial. I can see that. I'm first finding the zeros of this polynomial. That's better if you first find out the zeros of this polynomial. I can figure out this is a minus b whole square, x minus 2 whole square. So I'll write x minus 1 whole square. That means x is equal to 1 and x is equal to 1 only. The zeros of this polynomial is 2 less than this. Then conversely, can I say that? Can I say that the zeros of this polynomial is 2 more than this? One more time. It says zeros of this polynomial decreased by 2 results this polynomial. Then zeros of this when increased by 2 will give you the zeros of this polynomial. So if I write the next polynomial, that is x square minus bx plus c is equal to 0, what I can say, if I take alpha as the zeros of this polynomial, it is 2 more than the zeros of the previous polynomial. So it's 1 plus 1 plus 2, that is alpha comes out to be 3. And likewise, if I get beta, it is 2 more than the previous polynomial. So it's 1 plus 2. So beta also comes out to be 3. Now check here. Now here we are going to use the sum and the product. So what is the sum of the zeros as for alpha plus beta? What we know, sum of the zeros is alpha plus beta, which is equal to minus b over a. That's the standard formula. So sum is what? 3 plus 3, that is 6, is equal to minus of minus b is what? Positive b over a is the coefficient of x square. So b divided by a is b only. So b we got as 6. Now, as per the product of the zeros, it is what? Positive c over a. Product is this multiplied by this. 3 into 3 is what? 9. And that is c over a. C, as you can see, c is c only and a is 1 over here. So we get c is equal to 9. So we'll declare these to be the answer. Now I can see there is an option, that is option, the first option over here. B is equal to 6 and C is equal to 9 is the answer for this.